In this video, we're going to continue our transformations of exponential functions as we talk about stretching and compressing. So for any factor a greater than 0, the function f of x equals a times b to the x is stretched vertically by a factor of a if a is absolute value of a is greater than 1, is compressed vertically by a factor of a if absolute value of a is less than 1, has a y-intercept of 0a, has a horizontal asymptote at y equals 0 and a range of 0 to infinity and a domain of negative infinity to infinity, which are unchanged from the parent function. That also assumes it's going to be stretched, not reflected, because we did say absolute value. So example 4 says we're going to look at graphing 4 times 1/2 to the x. So go ahead and get some values here. Make a little table. X 4 times 1/2 to the x. So we'll go with like -3, -2, -1, 0, 1, 2, and 3. Okay, so for -3, so 1/2 to the -3 is going to be 8 times the 4. So that's 32. That's a little big. It's going to be beyond our graph. How about a 1/2 to the -2 times 4? That's 4 times 4, so it's going to be 16. Still beyond our graph. How about 1/2 to the -1 times 4? That's 2 times 4, so that's 8. We can do that. -1 is 8. And then how about 0? So it's going to be 1/2 to the 0 times 4 is going to be 4. That's our y-intercept. And then 1/2 to the 1 times 4 is 1/2 times 4, which is 2. Then 1/2 to the 2 times 4 is 1/4 times 4, which is 1. And then 1/2 to the 3rd times 4 is 1/8 times 4, which is 1/2. It's kind of nice because with that vertical stretching, you can really see without having to get like into 0.5 or as far as x values go, you can still see that incredible, exponential decay happening. So our domain here is -infinity to infinity. Our range is 0 to infinity. And our asymptote is still, there's been no vertical shifting, y equals 0. So here's our reflections. Graphing reflections. Reflections of the function f of x equals b to the x. The function f of x equals -b to the x reflects the parent function across the x-axis, so it's going to be reflected down. Has a y-intercept of 0, -1, and a range of negative infinity to 0. And that's what I was talking about with this. Up here, they talked about this being absolute value of a, having the range 0 to infinity. But if it's reflected down, because a was negative, it's going to be down there. So horizontal asymptote at y equals 0, domain of negative infinity to infinity, which are unchanged from the parent function. Now, contrast that with f of x equals b to the -x, reflects the parent function f of x equals b to the x about the y-axis, has a y-intercept of 0, 1, a horizontal asymptote of 0, y equals 0, and the range of 0 to infinity and a domain of -infinity to infinity, which are unchanged. So it's going to go basically reflected across the y-axis now. So here's our original. Here's negative leading coefficient. There's a negative in the front, so it reflects across the x-axis. And here's our original, and the orange is where it's been reflected across the y-axis because the negative applies the x first. So for example 5, we're going to graph the equation for the function g of x that reflects this graph about the x-axis. So the original function would look something like this. So we're at, so -1 is going to be 4, 0 is going to be 1, 1 is going to be 1/4, then 1/16, and it gets small pretty quick. Okay. That's our f of x. So g of x, I'll change colors for that. It's going to be reflected down below. So it would be hitting here, there, there, and there. Let's do that. Okay. And so we need to state the domain. Am I reading this wrong? It says, find and graph the equation for function g of x that reflects f of x equals 1/4 to the x. Oh, I got it right. Okay. 1/4 to the x across the x-axis. Okay, I guess I was looking in the wrong place. Yep, there we go. That's what I was after. Okay, let's go on to the next one. Summaries and translations of exponential functions. So this is putting it all together. So we have f of x equals a b to the x plus c plus d. So the basic parent function is y equals b to the x. Shifted horizontally c units to the left. Shifted vertically by a factor of absolute value of a. If absolute value of a is positive, is greater than 0, I should say stretched vertically. Compressed vertically by a factor of a if a is between 0 and 1, absolute value of a. And shifted vertically d units, reflected about the x-axis when a is less than 0. Note the order of the shifts, transformations, and reflections follow the order of operations. So write the equation for the function described below. Give the horizontal asymptote, the domain, and the range. So we have f of x is vertically stretched by a factor of 2. So that means we're going to be, our general function is f of x. So I changed colors. And I guess the computer's so slow at writing it, it had it still in red. That's funny. And then it changed to blue while I was in the middle of writing. F of x equals a b to the x plus c plus d. And so it's vertically stretched by a factor of 2. So a is 2. Reflected across the y-axis. So that means we're going to have a negative with our x. So negative with x. And then shifted up 4 units, so d equals 4. So we'll have f of x equals 2 for the a, b to the negative x, our b is e in this case, excuse me, e to the negative x, and then it was up 4 units, so plus 4. And that's it. Okay, this is a long video, I apologize. And that's it for this section.